Hello students, in this session we are going to learn Booth's algorithm. So first we will go through the flow chart of this Booth's algorithm, the description related to this flow chart, and we will be solving one or two numericals related to this algorithm. Basically, this Booth's algorithm is used for signed multiplication. Since we are aware that for multiplication we need a multiplicand and multiplier. So here in the flow chart, the first step what we need is A register and Q minus 1 register should be initialized to 0. In M, we are going to store the multiplicand. In Q, we are going to store the multiplier, and the count is n bit, right? So always we are going to check the count whether it has become 0. If not, we will repeat the loop. So let's see how we are going to perform this algorithm. So we are going to check the Q0 and Q minus 1 bit. If both the bits are same, that means either they are 1 1 or 0 0 respectively, then we are going to perform arithmetic shift right operation on the content of A, Q and Q minus 1. So that means we are going to shift right the content of A, Q and Q minus 1. After shift operation, we are going to decrement the count by 1. Okay. After decrementing the count by 1, check whether it is equal to 0. If it is not equal to 0, again go and check the bit Q0 and Q minus 1. If the Q0 bit is 0 and Q minus 1 bit is 1, then we are going to perform the addition of the content of A and content of M. A is a register which has been initialized to 0 at the start, and M is the multiplicand, right? So the addition result is stored in the A register itself. So after addition, again we are going to perform arithmetic right shift operation on the content of A, Q and Q minus 1. After shift operation, decrement the count by 1. If it is equal to 0, come out of the loop. If not equal to 0, again repeat the procedure. Now, if suppose the Q0 bit is 1 and Q minus 1 bit is 0 respectively, then we are going to do the subtraction of A minus M. That means we are going to subtract the content of M from A and store the result in A. So here you are going to keep it in mind that we are going to do the addition itself. That means we are going to take the 2's complement of M and we are going to add it with A and store the result in A. So when we do the 2's complement addition here, then it will be considered as a subtraction. Okay. So we are going to perform arithmetic right shift of the content A, Q and Q minus 1 after this subtraction, and the count will be decremented. Okay. So when the count becomes 0, then it will be the end of the process. Okay. So this is the flow chart for Booth's algorithm for 2's complement multiplication. The description of this flowchart has been given here. So the multiplier and multiplicand are placed in the Q and M registers respectively. There is also a 1-bit register placed logically to the right of least significant bit Q0 of the Q register and designated Q minus 1. The result of the multiplication will always appear in the A and Q register. See, if I multiply any two numbers, then the result of these two numbers, the product, will be stored into A and Q register. Initially, the value of register A and Q minus 1 are initialized to 0. So now the control logic scans the bits of the multiplier one at a time. So we are storing a multiplier in Q. So we will be always checking the Q0 bit one at a time. That means we will be check if there are n bit present in the multiplier, we will be scanning one bit by one bit. Okay. Now as each bit is examined, the bit to its right is also examined. So whatever may be the rightmost bit is that is Q0, that will be examined. So if the two bits are the same, that is Q0 and Q minus 1 are either 1 1 or 0 0, then all of the bits of the A, Q and Q minus 1 registers are shifted to the right one bit. Okay. So if the two bits differ, that means it can be 0 1 or 1 0, then the multiplicand is added to or subtracted from the A register depending on whether the two bits are 0 1 or 1 0. So if we observe from this flowchart, if it is 0 1, that means if Q0 is 0 and Q minus 1 is 1, then we are going to do the addition. And if the Q0 is 1 and Q minus 1 is 0, then we are going to do the subtraction, right? Next, after that, following the addition or subtraction, the right shift occurs. Okay. So if the bits are same, then also the right shift occurs. After that, if there is an operation for addition or subtraction, after that also the right shift occurs. Okay. So in either case, the right shift is such that the leftmost bit of A, namely A minus 1, not only is shifted into A n minus 2, but also remains in A n minus 1, right? So what we are going to, since we are going to shift to the right, then the A minus 1 bit is not only shifted into A n minus 2, but it remain as it is in A n minus 1 position. So this is required to preserve the sign of the number in A and Q. So it is also known as an arithmetic shift because it preserves the sign bit. Okay. So this was the explanation related to the Booth's algorithm. Thank you so much.